Hi everyone, welcome to this newest video. My name is Johan and together with me is a very special guest. It's Jits Langedijk from NVIDIA.
Hi Johan, good to be here again.
Thanks for being here. Today we're gonna basically give you an introduction to artificial intelligence. What is it? What is machine learning? What is deep learning? How do we apply it? And what kind of use cases do we see at customers that apply technologies like that? And Jits obviously is from NVIDIA, and together we would like to guide you basically through the basics and show you also how to apply that on the different types of solutions that NVIDIA together with ITQ could offer you.
Yeah.
So
last time we spoke about, or the first video together with me, we spoke about vGPU and the virtualization of a GPU, and that was all more focused on accelerating graphics, especially in the VDI environment. And a lot of people know NVIDIA, of course, for its GPUs and graphics acceleration and visualization and all that kind of stuff. But the GPU is also very important when it comes to computational resources as well. So. And especially when we're talking about high-performance computing, so HPC or AI, narrow AI, or machine learning and deep learning, a GPU is being used as well. Maybe even more for compared to graphics acceleration, but not everyone is aware of that. So a GPU, basically, you can use it for both the acceleration of graphics, but also for computational workflows. So we're going to dig a little bit into this, and as you said, like a high-over one-on-one on artificial intelligence, machine learning and deep learning. And maybe we should start off with this AI, this general AI. So if I, of course we got the light board, so we're going to use it. So let's try at least to draw a box which we call AI. Artificial intelligence. And artificial intelligence we can divide into more or less two types. So general AI and narrow AI. First of all, with artificial intelligence, it's not really new, especially general AI.
This existed for like decades, right?
Yes, somewhere around the 50s, people already started thinking and start to processing, or at least started to think about a supercomputer that mimics everything that we can do as a human being. Acts like a human being, interacts like a human being. And this is something that we see, well, to be honest, in Hollywood productions, right? We see these nice robots, these friends or enemies. So general AI, a computer that has the same characteristics as we as human beings have, we're not there yet.
No.
However, we do have narrow AI solutions. So AI solutions pinpointed to a specific task, like voice recognition, which we do with like an Alexa or a Google or with your iPhone, your Siri. Those are narrow AI solutions which are trained, and we're going to cover that later on. Training and inferencing, two different steps in the process. So the first thing I want to make sure that everyone understands, there's a difference between narrow AI and general AI. So we're going to talk more about narrow AI solutions. So and within the level playing field of AI, we have basically a segment which we call machine learning.
Sorry, basically a subset of AI.
Yes.
Yeah.
So, and machine learning is around for quite some time already. And this machine learning is more like, it requires a domain expert who understands everything in this domain, of course. And let's take a spam filter, for example. So you do some linear regressions on a subset of data, and you're just trying to, you had a great example, like a Nigerian prince that sends you a nice email, and you only have to wire some money, and then all of a sudden you're loaded, right? So we've all seen these emails, and luckily for me, I never spoke to anyone who actually replied to such emails. But in most cases, these emails are just flagged and sent to a special folder within your email client, and it's flagged as spam. This is something that you can do based on machine learning.
I think to make that example a bit more simple, it's quite, if you know how to script or how to code, you basically know how to create an if-then-else loop. You have certain different conditions, and based on that conditions, you have an output. I think it's quite hard if you use loops like that to create a loop that is able to detect emails from a Nigerian prince or from a fraudulous bank or something like that, and mark that as spam. So the number of conditions, it exceeds a certain amount of conditions that makes it hard to create a loop like that, if-then-else loop.
And it changes, of course, right? So when you receive this email from a bank which asks you to provide your PIN code or your social security number or whatever, as soon as you, like for example, you just take the header of the email and you make this script based on machine learning that detects automatically, well, this combination of words is flagged as spam or is thrown to trash right from the start. As soon as you maybe change some characters in the header, you use an exclamation mark instead of a letter, for example, then of course it requires this machine learning domain expert to change the code every time. So it's very labor intensive, error prone. So it does the job, but as soon as the amount of data increases, which, well, with big data today, we have huge amount of data. So we have data lakes all over the place. We have IoT sensors collecting data and generating data. So this machine learning can be a real challenge.
Yeah.
There's definitely a use case, or maybe the combination with deep learning and machine learning, where machine learning can be integrated into the entire process as well. But it's as I said, it's very labor intensive, and it requires a domain expert that exactly knows what the machine learning algorithms needs to do. Yeah. So next to machine learning as a subset of artificial intelligence, we also have deep learning. So I'm not really good at drawing at a whiteboard, but I'm getting there. So AI, machine learning, and deep learning. So deep learning again is a subset of artificial intelligence, and deep learning really addresses basically the challenges that we have with machine learning as well. When we have this huge amount of data, we want some software that trains itself instead of using this data scientist or this domain expert. So what we can do with deep learning is use a framework to create a model. And to give you a little bit of an example, you have a daughter, right?
Yeah.
How old is she today? Or well, not exactly today, but
10 months.
10 months. Okay, so maybe you already seen them or already offering them. You have these little books with only one picture per page that says this is a ball, this is a key, this is a car, this is a house, right?
Now at this moment everything is the.
Ah, okay.
Yeah.
Okay, so maybe in the next food. So now maybe in the upcoming years you see these books coming along, and what you're doing is actually it's training your child to recognize images.
Yeah.
So when we offer to a human being 10 times a picture, and just it's a random number, right? 10. But when we offer 10 times the same picture of different balls, like a tennis ball, a baseball, or a basketball, all of a sudden, between the neurons in the brain, there are connections being made.
Yeah.
And some connections that are not frequently being used, they disappear. And this is basically how we train, how we train ourselves and how our brain is built. And it's very low level, right? So bear with us. But all of a sudden now when you show her a football, without the label that it's a ball or football, she is able to recognize it as a ball.
Yeah.
So, and this is more or less as I always try to explain what deep learning is. So, let's take, these are the neurons in a brain, and we have, of course, multiple neurons, and there are connections between all those, all these neurons. A lot of, yeah, all complete?
All complete.
No, I'm missing this one,
Yeah.
and this one. Oh, I'm still training, right? So, so what we do basically with deep learning, we take this set of images of different types of balls, or maybe we always use cats and dogs on the internet, right? So we have all kinds of images with a cat and a dog, and these are all images that are well, labeled.
Yeah.
Right, so we know exactly what's on the image. And for example, we have 10,000 images of cats and 10,000 images of dogs. So we feed these images into a framework, and this framework is gonna extract the features on different layers. So in this case, it's a simple framework. It's got an input layer, an output layer, and some layers in between. Hidden layers, as we call them. And what we do is basically we feed all these images throughout the framework. And an image is either correct, yes, it's a dog, or no, it's not a dog. And when it's not a dog, we do some backward propagation to correct the flow throughout the framework. So every time some connections are increased and others are maybe disappearing or become less important. So when we do this multiple times, multiple epochs.
Yeah, an epoch is an iteration, right?
Yes, an iteration of this data set, and all of a sudden, or not all of a sudden, but after a lot of time, we have a framework that recognizes also unlabeled images. So all of a sudden we can feed the image a new image of a cat that it's never have seen before, but based on all the layers, all the hidden layers in the framework, it can recognize this is a dog or this is a cat.
And it basically outputs a predictability of, let's say,
yes,
the chance of this picture being a cat is like 95%.
Yeah, and it's maybe it's a dog, maybe it's 5%.
Yeah.
And based on this predictability, you can trigger an event, of course. So when we talk about face recognition, for example, and we want to find this lost child at a train station, for example, and we have a trained model with all kinds of faces of people that we already know, of course, because privacy is a big issue, of course, in this particular example. It has a predictability that for 90% this child is at platform 4, for example.
Yeah.
So you send the people over there to get the kid to his parents.
A neural network, like we call this, is for like you mentioned, for in this case labeling a cat or dog, or determining if it's a cat or a dog is fairly complex. But it could, there could be like 10,000 of different decisions, and that's definitely something you don't want to run in a sequential way, through an if-then-else statement. You could do that, but it'll take a long time.
Yes, for sure. And as soon as you're finished, your data set is probably outdated, and you need to retrain it. So there's no really a point. But as you said, especially when this is just 2 examples, right? But if you, I know in the early days there was some machine learning, deep learning being used, like with chess games, with Garry Kasparov, and there was this IBM Watson computer that could beat him. But if this computer was playing against you, there was a very big chance, I don't know about your chess game, but that you would beat it, because this was a model specifically trained against Kasparov and not against Johan van Amersfoort.
Right.
So there again, you need a data scientist to retrain it to play against you. And this is, of course, with deep learning, this is all different. Yeah, as you mentioned earlier today, with the AlphaGo game, where the options and the all kinds of sets, or basically the way you play the game, has so many variations. You need a different approach instead of machine learning. You need an approach like deep learning to have a computer beat a human being.
So after, if you haven't seen the Netflix documentary on AlphaGo, I highly recommend doing so, because it gives a really good insight on how the process was, how they went through the process of building that model and applying it during the game of Go. And what you're seeing there is that after every move, the deep learning algorithm is constantly rethinking of the next move, of the potential next move, and determining what the best move is to have the best outcome in terms of AlphaGo winning the game. Every move could have a million different choices of the move after. So the number of neurons within that trained algorithm is it's extreme, which requires a lot of parallelism. And a CPU in itself isn't that good in running parallel
jobs. I mean,
parallel jobs. Yeah.
So and this is what we refer to as training.
Yeah. So you basically take a large data set of preferably labeled data, or essentially labeled data.
Yep.
Feed that into a train or in a build model, and run those data sets through the model to get a trained model, which is able to detect or to run unlabeled data through the model and determine an outcome.
Yeah, exactly that. So you started with a structured data set, a labeled data set. Yeah. You do the training on the GPU. Otherwise, well, it takes simply too long. And once you got a trained network, like back to the cats and dogs, or at least the cat. There was one colleague that has a nice lawn in his garden, and there was constantly a cat, doing some things on the lawn it's not supposed to do. So we had a nice camera pointed to his lawn, and a small GPU which was able to detect whether there was a cat walking on the lawn. And as soon as it detected the cat, the sprinklers automatically
really?
So now his lawn is nice and green, and there are no cats anymore. But just a simple example, right? So, of course, this colleague, he needed to train a network to get a model, and now this model can be applied to make sure that there are no cats on his lawn anymore. So when you apply this trained model, then we're talking about inferencing.
Yeah.
Making use of a trained model, and this is the same as you use again, like Siri on your iPhone. What you do is basically inferencing, because there is a trained model which is able to understand the words that are coming out of your mouth and act, or at least you trigger some events.
Yeah.
So that's the difference between inferencing and training.
And training requires a lot of resources, computational resources, while inferencing could be...
It depends, of course, but again, if you just want to detect whether there's a cat walking on your lawn, you don't need a very beefy GPU, of course. But the same applies to autonomous driving, right? You get all kinds of information like radar, LiDAR, cameras. All this information needs to be processed in the inferencing phase within the car to make the right decision to change a lane or take a turn, for example, and use the indicators and all that kind of stuff. So again, yes, you need some GPU resources within the car, but it's completely different compared to the GPU resources that you need to train multiple models, of course, when you're talking about autonomous driving. Yeah. Because there, we need to know whether there's a cat or a dog in front of the car, but we need to know a lot more, of course, when we're talking about autonomous driving.
Yeah, so you mentioned the GPU a couple of times already.
Yep.
But and obviously, when we talk specifically about GPU, we think about GeForce GPUs or GPUs in the data centers, like the Tesla GPUs. But nowadays, basically every device has a GPU. You know, our phones, our tablets, like smartwatches, because if you can talk to a smartwatch and it'll execute a task. But you know what to think about? You mentioned a car. A GPU is used in a car to display output to, for instance, your radio, but the GPU is also used to execute your voice commands or to warn you if someone on a bicycle is passing by. So it's a perfect application of GPUs as well.
Yeah. So this is the same as if with a car. Of course, you got lots of data coming in which needs to be processed, and you need to process it in parallel. So you need a GPU. Otherwise, well, it simply wouldn't be safe to have this car driving around, and especially when you're using all these autopilot features, as we all have available. Well, most of us have available these days.
Yeah. Cool. Well, Jits, thanks so much for explaining this to us. In the next video, we'll talk about how to apply these different technologies on architecture, and how to integrate them with both NVIDIA solutions as well as VMware solutions, and how to simplify the deployment of deep learning frameworks from the NVIDIA GPU cloud. So thank you so much for watching, and we'll definitely see you next time. Did you like this video? Please subscribe to our channel because we have a lot more where this came from, and you'll be the first to hear when a new video is released.